Now this is a fun one, de Moivre's theorem.
De Moivre's.
Whichever. You can say it the right way or the wrong way. It's up to you.
And we're not telling you which one is which.
Okay, so all it says is we have this complex number in trigonometric form, which is what we've been talking about.
And remember, trigonometric form is really a great way to do a lot of things.
Yeah,
with
we
a
just
complex
did
number.
multiplying, we did dividing, and it was really easy.
Super easy.
So now if we want to do the complex number to some power, then there's this formula for that you take the r and put it to that power, and then you multiply the angle by whatever
the
your
power is.
And,
yeah,
and
I mean, it doesn't get any easier than that.
Can we think for a
no,
second?
we can't think.
Never mind, I didn't ask. We will think for a second about this. What if we had to do 2 plus 6 I to the 5th power?
Without a calculator?
Without a calculator, that's ridiculous.
Good luck.
You'd have to FOIL, distribute, whatever you want to call it.
A bunch of times.
A bunch of times.
Yeah.
You'd be really unhappy with us. Nobody wants that. So instead...
That could be the test question. That's how long it'll take.
Yeah. And so instead, we can do this formula if we have it in trig form. It would be easier to change this probably to trig form and then use the equations.
Right.
So we're going to...
And you still could do that without a calculator. But once you get that problem to trig form, you could do it in a matter of minutes instead of a matter of hours.
Right.
Yeah.
The first thing then that we have to do here is we have to change this into trig form. So our R, we do 1
Talk
squared
like a pirate.
plus 1 squared square root and get square root of 2.
Square root of 2, I.
No, not I.
R.
No, not R. And then cosine theta. Now, if you're thinking about this, we have this point 1 comma 1.
Please know what this one is.
1, 1. Oh, we just found out it was square root of 2. This is a 45-degree angle. Now, do we want 45 degrees or do we want radians, or does it matter?
I don't think it matters unless it's something in the directions like between 0 and 360 or between 0 and 2 pi.
Okay, and also keep in mind we're changing it to trig form, but we're going to change it back to standard form, so it really doesn't matter at all. Bless you.
Wow. Excuse me.
It really doesn't matter at all which kind of angle you use there, because you're just going to end up evaluating it.
And they're both going to be the same, so.
Yeah, so we're taking this, now that it's in trig form, to the 5th power, and de Moivre's theorem tells us that that means it would be the square root of 2 to the 5th power.
Right.
Cosine of 5 times pi over 4, which is 5 pi over 4. 5 times pi over 4.
Yeah, according to de Moivre's, it is 5 pi over 4, yes.
Yeah, and then sine, and these angles are always the same. You only have to really do that math once.
Just once.
So this
if you do your math on this and you get an angle for cosine different than the angle you get for sine,
you did something wrong.
There's a mistake.
Yeah. This is trig form. We could simplify the square root of 2 to the 5th power.
Sure.
And I'm going to write it out, but just think about it to yourself, and you'll probably get there pretty quickly. We're saying that we have this kind of situation going on. Well, these two make 2. These two make 2, so that's 4 square roots of 2.
That's
right?
Pretty easy.
Okay.
So easy a pirate could do it. Arr!
Yeah, totally. And we want this to be in standard form, which means we need to actually distribute. But check the instructions when you're doing this. They may want you to leave it in trig form, and that would mean that we were done.
Right. So from here, there's a couple different things that we could do to totally clean up the problem and be uber nerdy.
Yeah.
One is we could distribute like Mrs. Stevenson just said. The other one is that we could convert what the sine and cosine at 5 pi over 4 is and multiply that with 4 square roots of 2.
Let's do that.
Let's do it. Okay, sounds great.
Cosine of 5 pi over 4.
Negative square root of 2 over 2.
Okay. And how did you know that?
Well, because it's in the 3rd quadrant.
Well, but like, how would they know that?
Well, because 5 is bigger than 4, and if you have 4 pi over 4, that's 180 degrees.
Right.
So you're pi over 4 units past that.
Is it on the unit circle?
It is on the unit circle.
Okay. So that's another option. You could look at the unit circle.
You could.
The sine of 5 pi over 4
happens to be negative square root of 2 over 2. For all of the same reasons.
Right. Okay, so we have to distribute 4 square roots of 2 to both of these. Well,
square root of 2 times the square root of 2
is 2.
Yep. We just ascertained that.
Okay. And 4 over 2
is 1/2.
Is No, it's 2.
Right.
So that's 2 times 2, which is 4. That's negative 4. 4 square root of 2. Oh, that's pretty much the same thing.
Hey, minus 4i.
Yeah. So
look, we could have done 1 plus I all the way out 5 times, or bam, switcheroo, bam, done.
yeah.
That's what it is.
Yeah, that's what it is.